Hello and welcome. Thank you so much for joining us today for our California State Route 79 Freeway Conversion Project presentation. Before we begin, I would like to introduce you to our project team. My name is Matthew Jacobson.
And my name is Nicole Aquino, and we are the project managers for the senior project. Next, I'll turn it over to Jocelyn and the environmental team.
Thank you, Nicole. Hello, my name is Jocelyn Perales, and I am this year's environmental team lead.
My name is Kong Chen.
My name is Callum Merchant. Now I will turn it over to Na and the traffic team.
Thank you, Callum. My name is Na Li. I am the traffic team lead.
My name is Raymond Lee.
My name is Arodi Garcia.
My name is Miguel Obregon. We are the traffic team. Now I will let Ben introduce the geometric team.
Thank you, Miguel. My name is Ben Costello, and I'm the geometric team 1 lead.
My name is Ala Abu Alia.
My name is Asif Rahman.
My name is Dean Aker.
My name is Karen Gregorio Robles.
My name is Dayeli Rubalcaba. And now I will pass it over to Cesar to introduce Geometric Team 2.
Thank you, Nayeli. My name is Cesar Hernandez, and I'm the Geometric Team 2 lead.
My name is Douglas Annan.
My name is Melissa Wang.
My name is Michelle Ye.
My name is Borna Askari. Now I will turn it back over to Matthew.
Thank you, Geometric Team 2. As an outline for today's presentation, we'll cover an overview of the project, its environmental considerations, traffic analyses, proposed geometric alternatives, along with the decision process that led us to our selected alternatives.
This project is located in the city of Beaumont in Riverside County. SR-79 provides access to neighboring cities such as Temecula, Murrieta, Hemet, and San Jacinto. SR-79 is also located near major freeways such as the I-10, SR-60, and I-215. The project is approximately 55 miles east of Cal Poly Pomona.
More specifically, our study boundary is from East 1st Street to Gilman Springs Road along the SR-79. Through this corridor, the project focuses on intersections at California Avenue and Lamb Canyon Road.
The project scope includes identifying and analyzing existing problems in the area, also known as purpose and needs. The SR-79 corridor serves as an alternate route to neighboring freeways such as the I-215 and I-10. Considering this and the projected population growth by 2040, congestion is expected to increase. The level of service of the corridor must be better than D by 2045. Furthermore, accident rates at California Avenue and Lamb Canyon Road require for safety improvements to be made. Additionally, improvements are needed to current multimodal modes of transportation and environmental impacts for wildlife.
Based on the needs, the purposes of this project include improvements to accessibility, capacity, and safety along the highway to better serve the cities of Beaumont, Hemet, San Jacinto, and Murrieta, thus reducing accidents along the corridor. The project also will decrease traffic congestion generated by the projected population growth in the region by 2045, as well as improve accessibility for cyclists and pedestrians along the corridor.
This project also implemented different civil engineering disciplines such as surveying through digital terrain models, transportation through traffic models and simulations, as well as computer-aided drafting, structures through bridge designs, construction through our construction staging plan, and environmental considerations that Jocelyn will now discuss.
Thank you, Nicole. We will now take a look at the environmental considerations our team considered. One major document the environmental team is in charge of is the preliminary environmental analysis report. There are a total of 15 technical sections you can see on the screen that the team considered to be potential impacts to our project study area. After completing our analysis, we determined these 5 sections in bold impact our site significantly. Let's take a closer look at these sections.
To reduce impacts to the local community, our team took advantage of the vacant parcels surrounding the California Avenue interchange, shown in yellow. Partial takes of 2 residential zone parcels, shown in orange, were unavoidable, but alternative designs that required the relocation of nearby property owners were avoided. Right-of-way impacts weighed heavily into our alternative selection, especially at the Lamb Canyon interchange, where wildlife conserve land, shown in dark blue and green, bordered our site. Unfortunately, completely avoiding conserved land was not possible, and the selected horizontal alignment required 6 acres of MSHCP conserved land. At the completion of our project, the land of the original SR-79 alignment will be rezoned into conserved land, and new adjacent parcels will be bought to mitigate environmental degradation.
Our project strives to provide access to all users. The expansion and realignment of the SR-79 will allow trucks, cars, and motorcyclists to have an efficient travel path for the years to come. Also, in an effort to provide a complete street design, our team incorporated a share use path that runs from Lamb Canyon Trailhead 1 to Gilman Springs Road. Both pedestrian and bike users will have access to this path. In addition, due to the impacts of the conserved land, an animal crossing was designed in the southern portion of our project to allow the animals to roam freely without having to cross over the proposed freeway. The biological impacts were another component our team took into consideration when designing the SR-79 freeway conversion. Our site is surrounded by the multiple species habitat conservation plan and PQP conserved land. Our project approximately impacts 6.1 acres of MSHCP land and 0.1 acres of PQP land. These lands provide habitats for multiple endangered and threatened animals, as well as rare plants. The following slide lists some of the species that can be found on our site. The left image is a stepping kangaroo rat. The middle image summarizes the MSHCP land in green and the PQP land in blue. Finally, the last image is a California saptail. Kong will now discuss the geology impacts.
Our project site consists mainly of rolling terrain. The image shows the surrounding area, soils, and forest line. Now, expensive soil appears to prevail around the sites. However, there are a couple of forests that appeared within the sites. Therefore, we'll need to account for earthquakes in our structure designs and strengthen the existing soils. For design aesthetics, the realignment and widening of the SR-79 through rolling terrain caused large cut and fill. The summary of each earthwork quantity is summarized on the screen. This led our team to introduce retaining walls in area where size slabs exceeded design requirements. Next, Jocelyn will summarize our findings.
The following 5 environmental impacts were some of the major items that our team analyzed. Some of the mitigation options and potential solutions our team discussed to limit these included animal relocation, community outreach, further environmental studies, and construction sign and detours. Next, now we'll discuss the traffic data for our site.
Thanks, Jocelyn. Before we get into the specifics of traffic analysis, we first introduce how we obtain the traffic data, parameters, and what the level service is. The peak hour traffic volume was obtained from Caltrans traffic count sensors, Riverside County traffic analysis model, and the Southern California Association of Government model. The annual growth rate for traffic volumes between 2020 and 2045 is 3.8%, which is based on Caltrans 2017 Transportation Concept Report. The percentage of heavy vehicles on California Avenue and Lima Canyon Road is 10.4% and 28%, respectively. Level of service is used to determine how well a transportation facility is operating. 6 levels of service are defined from A to F, with level service A representing the best operating conditions, and level service F the worst. Next, Miguel will talk about the traffic analysis for existing and no-build condition.
This is a summary of the level of service for existing and no-build condition. Next, we will review the level of service for the existing conditions of the project. The existing geometry of State Route 79 was modeled using Synchro 10 to evaluate the current and no-build conditions for the years 2025 and 2045. The 2020 level of service was found to be A and F for California Avenue. Consequently, the 2045 level of service projection was F and F for California Avenue. For 2020, the existing intersection of Lamb Canyon Road and State Route 79 AM/PM level of service are B and B. Additionally, the 2045 AM/PM level of service projection was F and F for Lamb Canyon Road. Caesar and Ben will now discuss the geometric alternatives.
After environmental and traffic analysis, our geometric teams were able to develop feasible design alternatives for each interchange. We used design standards from the Highway Design Manual to ensure the safety of our designs, received industry guidance for best practices to improve our alternatives, and used professional programs such as MicroStation and Inroads to draft our designs.
This project will improve State Route 79 by converting it from a highway to an access-controlled freeway. We widened the roadway with the addition of 1 lane in each direction, increasing the capacity of the facility. We also realigned the 79 both horizontally and vertically so that the design speed of the roadway, according to current Caltrans design standards, is increased from 55 to 70 miles per hour. Finally, we added a truck climbing lane along portions of the northbound 79 where the grade exceeds 2%. Our team developed and designed 3 alternatives for the northern interchange at California Avenue and State Route 79. We designed each alternative with California Avenue as an overcrossing to State Route 79 while providing access for cars, bicycles, and pedestrians along California Avenue. Our first alternative is a hook ramp interchange. Our second alternative is a spread diamond, and our last alternative is a hybrid interchange incorporating elements of both the hook ramps and diamond design. I'll now pass it over to Karen to discuss our first alternative.
Our first alternative is the hook ramp interchange. The hook ramps interchange is generally designed when the freeway alignment runs parallel to the streets. In our design, only the southern portion of California Avenue runs parallel to State Route 79, while the northern portion maintains a 30-degree skewed angle. The proposed 4-lane bridge on California Avenue is designed nearly perpendicular to the 79, which minimizes the structure's cost. However, the hook ramp's design incorporates more drastic curves on the ramps than other designs.
The hook ramp alternative has 2 intersections and 4 ramps. For 2025, the southbound intersection AM and PM level of service are both A, and the northbound intersection AM and PM level of service are A and B. For 2045, the southbound intersection AM and PM level of service are A and B, and the northbound intersection AM and PM level of service are both B. Next, Allah will talk about the spread diamond alternative.
Our second alternative is the diamond interchange. The proposed 4-lane bridge is skewed at 75-degree angle to avoid the disruption of private properties at the expense of an increased structure's cost. This design meets drivers' expectations because diamond ramps are commonly implemented and easily understood by drivers.
The spread diamond interchange design will have 2 intersections. For 2025, the southbound intersection AM and PM level service are both A. The northbound intersection AM and PM level service are both A as well. For 2045, the southbound intersection AM and PM level service are B and C. The northbound intersection AM and PM level service are both B. Next, Nayeli will talk about the hybrid alternative.
Our third alternative is a hybrid interchange. This consists of hook ramps for the northbound ramps and a tie diamond for the southbound ramps. This alternative seeks to incorporate the near perpendicular bridge of the hook ramp alternative to decrease the structure's cost, along with diamond ramps on the western side of the State Route 79 to minimize the right-of-way and environmental impact. However, this design doesn't meet drivers' expectations as well as the other 2 alternatives. This is due to the different types of ramps being implemented on each side of the bridge.
The hybrid interchange design has 2 intersections. For 2025, the southbound intersection AM-PM level of service are both B. The northbound intersection AM-PM level of service are both B as well. For 2045, the southbound intersection AM-PM level of service are B and B. The northbound intersection AM-PM level of service are both B and B. Caesar will now discuss the Lamb Canyon design alternatives.
Our team designed 3 alternatives for the interchange at Lamb Canyon Road and State Route 79, as well as a shared use path from Lamb Canyon Trailhead 1 to Gilman Springs Road. Our first alternative is a tight diamond. Our second alternative is a spread diamond hybrid, and our third alternative is a trumpet. I'll now pass it on to Douglas to discuss our first alternative.
The tight diamond is an alternative that meets driver expectations and requires minimum construction cost. It also allows for construction within limited right-of-way areas. It is a common, simple design alternative that provides familiarity to constructors. One challenge with this design, however, is that it can be difficult for future expansion.
The southbound intersection AM and PM level of service are both A. The northbound intersection AM and PM level of service are also both A. For 2045, the southbound intersections AM and PM level of service are both A. The northbound intersections AM and PM level of service are both A as well. Next, Melissa will discuss the spread diamond hybrid.
The spread diamond hybrid has multiple advantages. The newly designed intersection allows for improved traffic flow due to added left turn movements on the northbound on-ramp. The interchange meets drivers' expectations and improves access to the SR-79 by utilizing on and off ramps connecting to the Lamb Canyon Road on the east and west sides. Cons to the spread diamond hybrid would be the limitations of expansion or widening on the northbound on-ramp due to the environmental constraints and mainline boundaries.
The spread diamond alternative at Lamb Canyon Road will have two intersections and provide access to the State Route 79 through the north and southbound ramps. Both intersections received a AM and PM level of service of A and A for 2025 traffic conditions. For the AM and PM 2045 traffic conditions, the southbound intersection received a level of service of A and A, while the northbound intersection received a level of service of B and B. Next, Michelle will discuss the trumpet alternative.
The trumpet hybrid alternative consists of loop ramps on the northbound and a tight diamond design on the southbound side. Trumpets are most useful when implemented on three-legged interchanges where most traffic on the terminating highway is going the same direction. This trumpet design has free-flowing traffic on the northbound direction. However, a drawback can be that it is hard to expand on if needed in the future and that the loops require a lot of right-of-way acquisition.
The trumpet alternative at Lamb Canyon Road will have one intersection at the southbound ramps. For the 2025, the southbound intersection AM and PM level of service are both A. For 2045, the southbound intersection AM and PM level of service are both A. Next, Borna will discuss the shared use path.
A shared use path serves as part of a transportation circulation system and supports multiple recreation opportunities such as walking and bicycling. Due to the upcoming development of Beaumont and San Jacinto, the path would provide accessibility and ease of multimodal transportation between the two cities through Lamb Canyon. Currently, the existing condition does not provide a direct path accessible for pedestrians and bicyclists. The 10 feet wide, 3.2 mile long path extends from the Lamb Canyon trailhead just north of Lamb Canyon Road to Gilman Springs Road, parallel to SR-79. It will have a 5-foot travel lane in each direction with grade variations of 2 to 10%. Now I will turn it back to Nicole to discuss the benefit-cost ratio.
Thank you, Borna. The benefit-cost ratio is determined by the quantified benefits and costs of each alternative. The benefits of this project were calculated based on values for total vehicle delay reduction, total vehicle stop reduction, fuel consumption reduction, and emissions reduction for each alternative. These values were taken from the Synchro reports and calculated accordingly. Furthermore, a cost estimate analysis was conducted based on the items shown here. The cost of each of these items were calculated for the current year cost and escalated to the project opening year cost. Based on these quantified values for benefit and cost for each alternative, the team was able to consider this in the decision matrix.
The weighted decision matrix for this project was created by the project development team in order to prevent selection bias when deciding our preferred alternatives at California Avenue and Lamb Canyon Road. The 10 categories included input from environmental, traffic, and geometric teams, and are ranked based on the following order in the slide. Our team then unanimously scored each alternative based on our project findings and our purpose and needs statement. This slide shows the weighted decision matrix for California Avenue, where the hybrid alternative scored the highest. And this slide shows the weighted decision matrix for Lamb Canyon Road, where the tight diamond scored the highest. Ben and Caesar will now discuss the preferred alternatives for their respective teams.
The hybrid interchange was selected as the preferred alternative for California Avenue. This alternative best met the purpose and need of the project while also having the lowest construction cost and greatest benefit cost ratio. The hybrid design also had a lower impact on right-of-way and environmental concerns. These factors led us to select the hybrid design as the preferred alternative.
For Lamb Canyon Road, our preferred alternative was the tight diamond. This alternative best met the purpose and need of our project. It impacted the conservation land the least while also having the greatest benefit cost ratio and has the best level of service. I will now pass it on to Dean and Douglas to discuss the roadway sections of the main line as well as our preferred alternatives.
Here is the typical roadway section for the widened SR-79 main line. The main line will have 3 12-foot travel lanes, 10-foot outside shoulders, and 10-foot inside shoulders on each side of the road, separated by a 2-foot concrete barrier. The northbound side of the 79 will have an additional truck climbing lane where the grade exceeds 2%. California Avenue will have 2 12-foot travel lanes in each direction and a median left turn lane. Bike lanes are included on both sides of the roadway.
The roadway section of Lamb Canyon Bridge consists of a 4-foot shoulder and 2 12-foot travel lanes each direction. There is a 4-foot median separating the east and westbound traffic lanes. Now I'll pass it on to Asif to cover the advanced planning study.
An advanced planning study was conducted at the SR-79 crossing over First Street and another one at California Avenue crossing over the State Route 79 for each northern alternative. Each study outlines the dimensions, grade, and elevation of the bridge along with the structure and barrier types used for the bridge. In this isometric view are some proposed elements for the SR-79. The bridge structure would contain cast-in-place box girders supported by column bent with pile foundation on both sides of First Street. On each side would be an abutment as well. The minimum vertical clearance of this bridge is 16 feet 6 inches above First Street. The bridge dimensions would be 115 feet long and 59 feet wide. Next, we will discuss the California Avenue Bridge. In this isometric view for the bridge are some proposed elements for California Avenue. The bridge structure would consist of cast-in-place box girders supported by a column bent with pile foundations in the middle of the 79. On each side would also be an abutment with a spread footing. Each alternative ensures that the minimum vertical clearance of California Avenue is maintained. For the hybrid, the bridge is 149 feet 6 inches long with a width of 86 feet. The vertical clearance used is about 49 feet 9 inches.
An advanced planning study was conducted for the Lamb Canyon Bridge, as well as the southbound on and off ramps. All proposed structures would have cast-in-place box girders supported by a column bent with a pile foundation. The bridge dimensions are 345 feet long and 61 feet wide. Now I will pass it on to Jocelyn to discuss construction staging.
Thank you, Melissa. The SR-79 freeway conversion consists of 6 construction phases. The order of these phases were chosen to minimize the impacts to traffic, the surrounding communities, and the overall cost of the project. Before zooming into each phase, let's take a closer look at the screen to get familiar with how the phases are divided. The first 3 phases involve changes to the northern portion of our project, from First Street to a meeting point 2 miles away from California Avenue. Phase 4 through 6 involve the changes from the meeting point to Gilman Springs Road. Let's take a closer look at each phase. This slide shows the changes that occur in phase 1. The parts you see in blue are included in this phase, and the items you see in gray are not included in this phase. On the left side, you can see the existing conditions, and on the right side, you can see what is built once the phase is complete. Phase 1 consists of the realignment and expansion of the existing northbound lanes from 2 lanes to 3 lanes from California Avenue to approximately 2 miles south of California Avenue. In addition, the construction of the east side on and off ramp, as well as the start of the California Avenue bridge construction will take place. Lastly, the construction of Lair Road will also occur during this phase. Phase 2 consists of the realignment and expansion of the existing southbound lanes from 2 lanes to 3 lanes from California Avenue to approximately 2 miles south of California Avenue. The construction of the west side on and off ramp, as well as the end of the California bridge construction, will take place. Lastly, the construction of the access and frontage road will be constructed on the west side as well. Phase 3 consists of the bridge construction at First Street, as well as the realignment and expansion from the lanes from First Street to California Avenue. Phase 4 consists of the realignment and expansion of the existing northbound lanes from 0.5 miles north of Lamb Canyon to 2.5 miles south of Lamb Canyon. The construction of the east side on and off ramp, as well as the start of Lamb Canyon bridge construction, will occur during this phase. Phase 5 consists of the realignment and expansion of the southbound lanes from 0.5 miles north of Lamb Canyon to 2.5 miles south of Lamb Canyon. The construction of the west side on and off ramp and the end of the Lamb Canyon bridge construction will occur. Lastly, the start of the shared use path will begin. Finally, phase 6 consists of the realignment and expansion of the lanes starting 2.5 miles south of Lamb Canyon to Gilman Springs Road. The end of the shared use path and the construction of the animal crossing will occur during this phase. Now, I would like to pass it over to Asid with ARVR.
Thank you, Jocelyn. For our project, the models for each alternative was created using the software Autodesk InfraWorks and aesthetically rendered using the program Twinmotion. Each model has allowed students to be fully immersed into the surrounding conditions and have a better understanding of the project in the environment built. The models can be seen using the QR codes or the links on the screen. Now I'll pass it on to Matthew to go over the website.
We now invite you to visit our project website using the link below on the screen. Our project website contains all of our geometric alternatives, environmental considerations, traffic analysis, and project documents, along with AR/VR content that you can view after this presentation.
We also would like to thank our advisors for their guidance throughout this project. Thank you to our faculty advisors, Dr. Zhang, Dr. Wu, and Dr. Chang, and to our Caltrans District 8 advisors, John Bumps, Justine Yu, and Jason Collado.
And with that, this concludes our presentation on the California State Route 79 Freeway Conversion Project. On behalf of the entire team and Civil Engineering Department, we would like to thank you so much for joining us today and listening to our presentation. We will now open it up to live Q&A to answer some of your questions regarding our project.